Hi, everyone. My topic today is the file data ingestion pipeline driven by liquid template. I want to share with the community about how we in Northwell using the liquid template to transfer the data into FHIR R4 and store them into Google file repository and other technology we use to achieve that. My name is DQ, you can call me DQ, Deqiang Hu. I'm the leading software engineer of Northwell Health. I have been working with Northwell Health for 6 years, and right now I work with in the innovation team. Northwell Health is one of the biggest hospital systems in New York area. We are developing a virtual assistant program for our care providers, doctors and nurses, so they can access patient data at their fingertip. For example, when the nurse manager arrived, she or she can learn how many patients in the unit and who might be discharged today. Or the doctor want to receive alert if the patient's lab result is arrived, or what's the result of the patient's latest lab test result. Our data platform is FHIR. My responsibility is to ingesting the data into the file repository. The data is coming from our in-house health information exchange server. We route all the message coming from different data source to a queue, and we consume the message coming from that queue. We have quite some challenge when we implement this pipeline. The first one is the dynamic nature of the file resource. For example, you may think the patient is a static resource. A human being is always there. How could that be changed? But in real life, for example, when we admit a patient, the hospital or the lab may already assign an MRI to the patient, and maybe later on someone found out the patient already in the system, so they want to correct that, reassign the MRI for that patient. Or if the patient has been to another hospital or stopped by the COVID test site and the patient already in the system. Other cases like the typo of the patient name, phone number, things like that. The other major other resource keeps changing is the encounter. We may move the patient from one bed to another bed, or from waiting room to the surgery unit, from one room to another room. For our application, find the location of the encounter is critical. Otherwise, we don't know who is the patient within the unit. The second challenge is the difference within our system, especially like terminology. Although we all follow the Agile 7 standards, but each facility or even each department may have a different standard of codec. For example, you can see here, some using the OTH means other, some using the other, or some using the OT. So a related person probably will have a multiple codec indicating this is other relationship of the patient. We haven't mentioned about how we code the ARCS norm code yet. Besides the different of terminology, the workflow is also different. Some facility probably will discharge the patient with the ADT L3 message, but some will do nothing. Even within one department, for example, the encounter of a mother probably will be discharged by the ADT L3, while the encounter of the newborn baby will never be updated. Finally, the least happened, but not the least important, is the human error. For example, typing extra quotation mark in the data, or typo of the patient name or patient phone number, or even even the program make a lot of error as well. So we are building our pipeline on Google Cloud. The technology we involved is the healthcare API, pops up, Dataflow, BigQuery, and we're using the liquid template to perform the data transformation. A little history about how we implement our file repository. We start our file repository in 2020, at that time on STU3, and in 2021, we moved to R4. By the end of last month, we already have a 3 terabytes of data store. And every day we have 500,000 to 2 million file bundle ingested, 100,000 to 300,000 patient data point updated per day. The data point means the patient encounter, observation, condition, medication request, things like that. We divided our file resource into 2 big categories. A static resource, which will not insert or update on the fly. For example, location, like a facility, unit, weight, room, or bed. Those data rarely changed. And also the practitioner, those are the residents, for example, their resident joined the Northwell or some doctors retired. For the static resource, we are using the scheduled data flow to insert or update this resource once a day or once a while. The other resource, which, for example, like account appointment, immunization, which may be inserted, updated, or deleted every time we receive the HL7 message. We are using the streaming data flow to insert or update those data. I want to clarify here, static doesn't mean those resources will not be updated. For example, practitioner, we probably will insert a new identifier for the practitioner. And the dynamic resource doesn't mean those resources will be updated. For example, like observation, once we insert an observation, we rarely update those observations. Statics or the dynamic just mean here, we won't create the location or practitioner resource when we receive the HL7 message. We're using the liquid template to perform the data transformation. I'm not going to cover the detail of the liquid template. It was an open source template language created by Shopify. Since it's open source, there are quite some open source projects support that. Microsoft recommends the file convert project to us, and we use it as a blueprint to implement our own solution. Although we are not using the C#, but we found the Python library to support the liquid transformation. The other reason we're using the liquid is that because it's very simple. What you see is what you get. For example, you can see here, we can ask the business analysis to create a sample JSON file, and he can decide which property are critical for our application. And then the developer will just come in and update the JSON file to fill in the detail and create the template. As you can see, it's pretty simple to follow. Liquid template also support the include operation, so we can modularize the template. For example, here you can see the address. We are not putting into the address detail like a street or city, state in the patient template. We just using the include to include data type address liquid, including the address in the patient resource. We also implement some of the customer filter. For example, like here you can see the get code. So we can turn the different code string coming from the HL7 message into the HL7 standard code. For example, like a language code, we have like a JP or Japan indication the patient using the Japanese, but we convert them into a actual standard. Here's another example of an encounter template. We also using the get code to convert the, for example, the encounter classes into the actual standard. Data normalization, you can see here we have a 2 JSON file. This is what the get code filter is used for. We maintain a lookup file for each code need to be converted. So we can put the actual 7 standard terminology into our file repository. For example, the left side is the relationship role, and the right side is the condition status. We are not, yeah, you can see that we convert the A to active, or 5556 level 3, yeah, convert that one to active. For our application, not all data is coming with the actual 7 event. For example, like location, attending physician, those data are not coming from ADT, but we store in the external database. So when we perform the data transformation, we will read the data from other resources and put the data into the final JSON and send it to file repository. So this is a piece of code to calling the back to the database. And you can see once we call the filter encounter information, then we put in the retrieve the data into the final template. And so we can have the location and practitioner information into the encounter instance. We receive millions of actual 7 messages per day, but not all the data has the same weight. For example, like the patient or the encounter resource come in the ORU or VXU events are not considered to be source of truth. So we may skip the resource coming from the message. So we're using the conditional insert in this case. So if there's no patient or encounter resource related to the ORU message, we quit one. But if there's already a patient or encounter resource, we will not update the patient or encounter resource for based on the ORU message. Also, there's a lot of data coming from some other tools which is not relevant to our application. We simply skip those data altogether. Other cleanup is that specifically inside our organization, we put in some of the department, they put in some special character inside the code or identifier, which is not supported by file. So we need to clean up those data as well. Not all actual 7 message may need transfer to JSON. For example, like ADT A18 or A47, which may involve in the change the reference of a certain reference. For example, the A47 change patient identifier list. This message intended to update the identifier list of the patient. Most time it means move one MRN from one patient resource to another. But indeed, it means all the resource encounter observation, medication requests relate to that person, patient resource, they need to move to another patient resource. So in this case, we don't need to transform into a template, but we need like get all the resource and update the subject or patient reference of this resource. Let them point to a new patient reference. So in this diagram shows we are using the partition of data flow to separate the business logic. So the left side do the transformation and the right side do the lengthy file operation. We have some here we have some lesson learned. When ingesting the data into the file, there always error happened. There's a you can see here the typical error we received in months. Most error relate to the, for example, duplicate record, for example, duplicated practitioner resource. For example, inside the bundle, if we are trying to find the condition, we are using the conditional reference to find the practitioner resource with identifier 1, 2, 3, 4. But if we have 2 practitioner resources have the same identifier of 1, 2, 3, 4, we will encounter the search criteria are not selective enough error. Most time when we encounter this error, which means we have data missing, that's not acceptable. So we record the error and store the original message and reprocess the event again, so we can minimize how many data missed. Validation, without validation, we cannot feel confident in our data. Specifically, this, yeah, for example, if we want to check what's the latest lab result, we imagine we want to check all the 100,000 lab tests. How many, which we probably end up about 500,000 diagnosis report and millions of observations. If we want to call the file to check each record, that takes hours. So we're streaming our file data into a BigQuery table and running the validation against between the BigQuery table against other database. So we can, yeah, it will just take minutes to validate our data. This step is critical at the beginning. We are not validating the format of the file, but or the profile of the file, but we are more validating the accuracy of our data. There are always things happening. For example, sometimes the middle tier server is down, so we cannot receive the message, or suddenly a new program go live and we receive a new message type we cannot process. So monitoring how the system is performing is critical. We fully utilize the Google Cloud Monitor and Alerting service. Like here you see, we create a dashboard, so we can monitor how many messages are coming into the system, where is the delay, how many error message we need to resend. So in case anything happened, we can get involved as quickly as possible. Same is alerting. If something happened, we will get the alert during the night, and so the support engineer can take action to recover the process. Logging is critical. We cannot stress much more than that. As you can see here, we found some new code value we haven't supported yet. So going into the logging, we can easily identify the problem and put up our solution based on that. The last, we know the problem is always like sometimes always problem happen. So we need to start the data flow. We know we can start the data flow by using the command line, but in case like emergency, you are on the road and all you can access is your cell phone, or someone is on vacation. They're probably not aware how to start a data flow. So we're using the Google Cloud Scheduler. Basically, what we did is generate the data flow template and create a schedule task in the cloud schedule. So in case, for example, the support engineer received the alert, so they can come to the cloud scheduler and simply restart the data flow. This is similar like what we did to restart the Windows service. So it's very convenient for us. So yeah, that's highly recommended. Yeah, that concludes my presentation. Here I can answer if you have any question, and also thanks for your time.
I don't see any questions in the Q&A on Huva. Do we have any questions in the room?
So are you calling the .liquid transform engine in process?
Yeah.
Or do you have that behind a service, or how are you doing that?
Well, we have a liquid template in the data flow. Basically, we have you're aware that the Google have the data flow application. Yeah, that's Apache Beam. So within that data flow, we calling the data transformation there. Yeah, like this one.
Okay, is it in the cloud in a Logic app?
It's kind of like a Microsoft Logic app.
Okay.
but it's based on the Apache Beam platform.
And so if the templates themselves are file-based?
The
Are those-
template itself themselves is a file-based, but the template is like a JSON. Yeah, it's a text format. We store on that cloud, and within the using the Python library to loading all the template into the memory, and when we got the data, we apply the data on top of that template.
Okay, so how does the cloud piece know about the files?
It's a yeah. That one actually you can really refer to the Liquid template, the web page, because that's a pretty powerful tool there. You can also refer to what Microsoft have. Yeah, you see here. Yeah, let me go to that page. The Microsoft recommended the file converter. This is an open source project recommended by Microsoft. So you in there you can they have this code is a C# code. This code basically reading the template and combine read the data and using the C# programming to convert the data into the other JSON.
All right, thank you very much.
Well, we are out of time. One question has popped up in Huva. If DQ, you wouldn't mind going. Oh, two questions. So you have a couple questions to answer in Huva, and if people in the room didn't get their questions answered, you can also post your questions there.
Yeah.
Thank you so much for a great presentation.
Yeah.